So hello everyone, myself Anandi, and in this session, I'm going to discuss the AIET 3 Class 11 JEE question and answer with you, okay, from chemistry. So I'll be dealing with some important questions and the questions which you find it very difficult. Okay. So moving on to the first question for today, it is question number 31, which you can see on the screen. So in which case is the number of molecules of water maximum? Option A, 18 ml of water. Option B, 0.18 gram of water. And option C, it is 0.0024 liter of water vapor at 1 atmospheric pressure and 273 Kelvin. And option D is 10 to the power minus 3 mole of water. Okay. So we are asked to find out the number of molecules. Only if we are finding out the number of moles, we can get the number of molecules. So let me go with the first option, that is option A. So 18 ml of water is given. So 1 mole of water contains Avogadro number of molecule, which is 6.022 into 10 to the power 23 molecules. Okay. So 1 mole of water means what is the molecular mass of water? And for hydrogen it is 2 and for oxygen it is 16. So the total is 18. So 1 mole of water contains 18 gram of water. It contains 18 gram of water. Okay. And to find out the number of moles, we need mass and molar mass. Molar mass we know. And how to find out the mass? From density formula. Density is equal to mass by volume, right? So from this, what is mass? It is density into volume. So what is the density of water? It is 1 gram per cc, right? And the volume given here is 18 ml. So into 18 gives you 18 gram of water. So mass is also again it is 18. Okay. Now 18 ml of water contains, it also contains 18 gram of water, which is nothing but your 1 mole of water, which it is equal to 6.022 into 10 to the power 23 molecules. Okay. So this is what we are getting from first option. Got it? Now coming to option B. So it is 0.18 gram of water. So what it is? The number of moles will be 10 to the power minus 2 moles, right? Since it is 0.18, it is 10 to the power minus 2 moles. Got it? And what is the number of molecules? It is 6.022 into 10 to the power 23 into 10 to the power minus 2. So what is the answer? 6.022 into 10 to the power 21 molecules. It is equal to this. Okay, and coming to option C. So volume is given to us and pressure is given, temperature is given. So from PV is equal to nRT, N is equal to PV by RT. So what is the pressure value? It is 1 atmospheric pressure and the volume is 0.00224 liter and the gas constant R value is 0. Since it is given in liter atmosphere, it is 0.0821 and temperature is given as 273 Kelvin. And on solving this, you will get 10 to the power minus 4 moles. 10 to the power minus 4 moles means Avogadro number into 10 to the power minus 4 moles. So it will be equal to 6.022 into 10 to the power plus 19 molecules. 10 to the power plus 19 molecules. Got it? And coming to option D, it is given as 10 power minus 3. So number of moles is 10 power minus 3 moles. So Avogadro number into 10 to the power minus 3 gives you 6.022 into 10 to the power 20 molecules. 10 to the power 20 molecules. Okay. So from the given 4 options, the option which contains the maximum number of molecules is option A. Since it contains 10 power 23 molecules. Here it is 10 power 21 and 19 here and here it is 20. So the maximum number of molecules is present in option A. So that is the correct answer. Okay. Hope this question is clear to you. I'll go for the next question. That is question number 32. So the ratio of masses of oxygen and nitrogen in a particular gaseous mixture is 1:4. The ratio of number of their molecules. The ratio of number of their molecules. So again, you have to find out the number of moles. The number of moles of oxygen divided by number of moles of nitrogen. The ratio we have to find out now. So this ratio only we are asked to find out. And what is number of moles? It is again mass by molar mass. So the mass of O2 divided by molar mass of O2 whole divided by the mass of N2 divided by the molar mass of N2. Okay. So what is the mass of oxygen? It is 1:4. So the mass of oxygen is 1 and the molar mass of oxygen is 32. Mass of nitrogen is 4 and the molar mass of nitrogen is 28. Right? So on solving what we get? We get 28 divided by 32 into 4. So the denominator of the denominator goes to the numerator. And here on solving this, we'll get 7 by 32. So the ratio is 7:32. So option B is the correct answer for this question. Got it? Such an easy question and it is very important. Got it? Now coming to question number 33. The most abundant elements by mass in the body of a healthy man, a healthy human adult are oxygen, carbon and nitrogen compositions are given, and the weight which is 75 kilogram person would gain if all H1 atoms are replaced by H2 atoms. H1 is the proton and H2 is the protium and this is deuterium, right? So the mass is different. They are the isotopes of each other. So what we have to find out? We have to find out the change in the mass. Change in the mass we have to find out. So first let me find out the mass of H1. That is the weight of H1 and let me find out. It is equal to, so the weight is 10% of 75 kilogram. Okay. So you can see the mass is 10%. Okay. So what is 10%? It is 10 by 100 into 75 kilogram. In which it is 0 gets cancelled. 75 divided by 10 is 77.5 kilogram. Okay. And since the mass of H2 is double, H2 is having double the mass of H1, right? Since H2 is double mass of H1, since the mass number increases by twice H1, the mass of H2, it will be equal to 7.5 into 2. So which is equal to 15 kilogram. Got it? So this is the mass of 15 kilogram is the mass of H2 and 7.5 kilogram is the mass of H1. It is the mass of H1. So now what is the increase? That is, what is the change? What is the increase in mass? Increase in mass, delta W will be equal to the mass of H2 minus mass of H1. So the H2 mass is 15 kilogram and H1 mass is 7.5 kilogram. So which is equal to 7.5 kilogram. So this is the change. This is your change in mass. It is increase in mass. So it is option A. Option A is the correct answer for this question. Okay. So first we are finding out the mass of H1 from the given composition of hydrogen. Then since the mass of H2 is twice the mass of H1, we are just doubling the 7.5 and from that we are getting 15 kilogram. Then by subtracting each other, the change in mass, increase in mass is found out. Got it? Yes. Then I'll go for question number 34. Suppose the elements X and Y combine to form two compounds XY2 and X3Y2. When 0.1 mole of XY2 weighs 10 gram and 0.05 mole of X3Y2 weighs 9 gram. The atomic weights of X and Y are. What we have to find out? We have to find out the atomic weight. So how to find out the mass? Atomic weight is nothing but the mass, right? So from the number of moles only you can get the molar mass. Number of moles is equal to mass by molar mass. No, from that only you can get the mass value. So for that I need to find out. I have to take XY2 and X3Y2 separately, and I have to find out the mass first. So you can see the number of moles here. Okay, it is 0.01 mole of XY2 has 10 gram. Okay, and now only one x we are having and 2y. So 2x plus 2y is equal to 10 by 0.1, which is equal to 100. So it is nothing but the number of moles is equal to mass by molar mass formula only. This is the number of moles, and 10 is the mass given there, and x plus y is the molar mass. Okay, so molar mass is now 100. So what is x from here? X is equal to 100 minus 2y. Okay, so now this is equation. Let me take this as equation 1. Now coming to x3y2. So 0.05 mole of X3Y2 contains 9 grams. So what it is? It is 3x plus 2y will be equal to, this is the molar mass, it is mass by number of moles, which is 0.05. So I am using number of moles is equal to mass by molar mass, from which the molar mass is equal to mass by number of moles. So this equation only I am using here. Okay. So 9 by 0.05 will give you 180. So this is taken as equation. Now substitute equation 1 and 2. So substitute the value of x in equation 2. So the equation 2 becomes like 3 into 100 minus 2y plus 2y, which is equal to 180. Equal to 180. So just substitute, and on solving this, it is 300 minus 6y plus 2y will be equal to 180. Okay, and from this the y value will be equal to 30. Y value is equal to 30. Now substitute this y value in equation 1. The equation 1 becomes x is equal to 100 minus 2 into 30. So 2 into 30 is 60, and 100 minus 60 is equal to 40. 100 minus 60 is equal to 40. Okay, x value is 40 and the y value is 30. Got it? So option B is the correct answer. So what we are doing here? So try to get the molar mass first and get the value of x and y. So that is the atomic weight of x and y. Okay. Fine. I'll go for the next question, which is question number 35. The radius of the second Bohr orbit for hydrogen atom is dash. The Planck's constant, mass of the electron, charge of the electron, and permittivity of vacuum, everything is given to us, and we have to find out the second Bohr's orbit radius. Okay, so we know that the radius for hydrogen and hydrogen-like species can be calculated by 0.529 into n square by z Armstrong formula. Okay, well, now the n value is nothing but the orbit value. So it is second Bohr orbit. So means n value is equal to 2. And the atomic number z for hydrogen is 1. So substitute n and z here in this r value, r formula. It is equal to 0.529 into 2 square, that is 4, and divided by 1. So 0.529 into 4 will be equal to 2.116 angstrom, which is approximately equal to the correctness. And this is the formula which we are using here in this question. So no need of substituting H, mass and charge. Okay, you can do in that way also, but it is not necessary here to get the answer for this. Okay. Now moving on to the next question. This question number 42. So consider the following reaction and the values of X, Y and Z in the reaction are. So what we have to do? To balance a redox reaction, we have two methods. One is oxidation number method and the other one is half reaction. So let me use the half reaction method here to solve this and to get the value of X, Y and Z. So in the half reaction method, what is step number 1? So step number 1 is dividing the given equation into two half reactions, right? So divide the equation into two half reactions. So the one is oxidation half reaction, the other one is reduction half reaction. So let me write the oxidation half reaction. Which element has got oxidized? It is manganese, right? So manganese, manganese is getting reduced. Manganese is getting reduced. Just a second. Manganese is getting reduced here. So who is getting oxidized? C2O4 2 minus is getting oxidized. So it is C2O4 2 minus, in which the oxidation state of carbon is +3 and it is getting oxidized to CO2. Is getting oxidized to that is 2CO2, in which the oxidation state of carbon is +4. Okay, so this is oxidation. And coming to the reduction half reaction. So manganese is getting reduced. In MnO4 minus, the oxidation state of manganese is +7 and it is getting reduced to +2. It is getting reduced to +2. So first we have to divide the equation into oxidation half reaction and reduction half reaction. Then what you have to do, you have to balance all the atoms except oxygen. You have to balance all the atoms except oxygen and hydrogen. So that is step number 2. So balance all the atoms except oxygen and hydrogen from the given two half reaction. So in the first oxidation half reaction, you can see the left hand side also we are having 2 carbon and right side also we are having 2 carbon and 4 oxygen. That is balanced. Whereas in case of reduction half reaction, we have only 4 oxygen in the left hand side, but there are no oxygen present in the right hand side. So what we have to do? We have to add H plus and H2, which is already given there in the equation. We have to add H plus in the left hand side and H2O in the right hand side to balance the oxygen. Now you see we can put 4 here to balance the oxygen. Now 4 into 2, 8 hydrogen. So we have to multiply the H plus by the number 8. Now all the atoms including oxygen and hydrogen, they are also balanced. Okay. And now the next step. So balance all except oxygen and hydrogen and then balance oxygen and hydrogen also. Okay. So step 2 and step 3 I have did in the single step itself. And next what we have to do, we have to balance the charges also, right? So redox balancing involves the balancing of atoms as well as the balancing of charges. So all the atoms are balanced, but all the charges are not balanced. So we have to check with the charge here. So in case of this reduction half reaction, you check the charge. It is 1 into -1 is -1 and 8 into +1 is +8. So what is the charge in the left hand side? The 8 minus 1 is +7. And in case of manganese, you see here we are having +2 and here 4 into 0, 0. So in the product side, the charge is +2. Now from +7 to +2. So 5 electrons are gained, right? 5 electrons are gained. So what I have to do? I have to put 5 electrons in the left hand side. I have to put 5 electrons in the left hand side. So the equation becomes like this. So the step 3 is balance the charges. So MnO4 minus and 8H plus 5 electrons gives Mn2 plus and 4H2. Now you can see that the charges are balanced. In both the sides we are having plus 2 plus 2. So now here 5 electrons are gained. So means in the oxidation half reaction, there should be the release of the 5 electrons. Right? Then only the loss of electrons and gain of electrons, they become equal. So in case of oxidation half reaction, you can see for one carbon, the change is from +3 to +4. So one electron is lost. One electron is lost for one carbon. Since we are having 2 carbons, so what we have to do? We have to multiply the number 2 here. So means the 2 electrons are lost for 2 carbons. Okay. But then you see the number of electrons lost and number of electrons gained, they are not equal. So let me write the equation first. This C2O4 2 minus giving 2 CO2 plus 2 electron. You can see the number of electrons lost and gained, they are not equal. Okay, let me take this equation as 1 and let me take this equation as 2. So what I have to do? Let me multiply the equation 1 by 2 and equation 2 by the number 5. Okay, so multiply the equation 1 by 2. So what will I get? I'll get 2 MnO4 minus plus 8 into 2 16 H plus 5 into 2 10 electrons gives 2 Mn2 plus 4 into 2 8H2. Okay, now multiply the second equation by 5. This 5C2O4 2 minus giving 10 CO2 plus 10 electrons. Got it? Now you can see that the number of electrons lost and gained, they are same. So from this two equation, cancel the terms which are common to each other. That is 10 electron gets cancelled and the remaining left hand side, right hand side part is written. Okay. So we get MnO4 minus is having the coefficient of 2 and C2O4 is having 5 and H plus is having 16. Where 2, 5, 16 will be the coefficient of X, Y and Z. Okay, for this question. So option A is the correct answer for this question. Coefficient of X is 2, Y is 5 and Z is 16. Okay. So what you do for the half reaction method, divide the two given equation into 2, like oxidation and reduction half reaction. Balance all the atoms except oxygen and hydrogen, and then balance oxygen and hydrogen also by adding H plus and H2. Okay, now all the atoms are balanced. Now to balance the charges, I am adding electron in the left hand side. Now the electrons lost and gained should be equal. So that's why I am multiplying by the corresponding numbers and getting the same value of electrons lost and gained. And then on cancelling the common terms and writing the LHS and RHS, accordingly I get the values of X, Y and Z. Okay. Yes. So this is called as redox balancing. Now coming to next question. Question number 44. At standard temperature and pressure, the volume of 7.5 gram of gas is 5.6 liter. The gases. So we have to find out the gas. So option A NO and option B it is NO again. It is not NO, it is actually N2. Okay. And option C is CO and option D is NO. So we have to find out the gas from the given volume and the mass of the gas present. So 5.6 liter is given as volume. 5.6 liter at standard temperature and pressure contains 7.5 gram of the gas. Now, what is a molar value volume? It is 22.4, right? 22.4 liter at standard temperature and pressure, they contain 7.5 into 22.4 divided by 5.6. So on solving this, you will get 30. So 30 gram will be produced from 22.4. So what is the molar mass? This is nothing but the molar mass. So the molar mass will be 30 gram per mole. Okay. So which of the given 4 gases will have 30 gram per mole as the molar mass? So it is option A, because for NO, the molar mass will be, for one nitrogen it is 14 and for one oxygen it is 16. So 14 plus 16 is only 30 gram per mole. Okay. So option A is the correct answer for this question. Okay. Then coming to question number 46. For same mass of two different ideal gases of molecular weights M1 and M2, plots of log B versus log P at a given constant temperature are shown. Identify the correct option. So we have to find out the correct relation from the given information. Okay. Let me go with PV is equal to nRT, where N is your mass by molar mass, that is weight by molar mass into RT. And let me take this WRT as K. So it becomes K by M. It becomes PV is equal to K by M. PV is equal to K by M. Now taking log on both the sides. So log P plus, since they are in the multiplication, it is, you have to put plus. So log P plus log P is equal to log of K by M. Log of K by M. Okay, you can see the log K by M value here. This is for M1, and for M2 it touches here. M2 touches here. This is M1. This is for M2 and this is for M1. So you can see that M2 log K by M2 is greater. Log, it is actually log of K by M2 and this is log of K by M1, right? So K by M2 is greater, log K by M2 is greater than log of K by M1, which is nothing but K by M2 greater than K by M1. You can see the denominator is very less. M1 is very less, means that is the one which is having the greatest value compared to the other. The denominator increases, the whole value gets decreases, right? If M1 is 4 and K by M1 will be less. So that is the relationship given. So the relationship between M1 and M2 is M1 greater than M2. So option A is the correct answer for this question. Okay. Yes. So next, coming to question number 47. Two closed bulbs of equal volume containing an ideal gas initially at pressure Pi and temperature T1 are connected through a narrow tube of negligible volume as shown in the figure below. The temperature of one of the bulbs is then raised to T2. The final pressure is. So two different systems are given to us and we have to find out the final pressure. So let us consider N1 plus N2 is equal to N1 dash plus N2 dash. Okay. So N1 is the number of moles of the first respiration. So it is from PV is equal to nRT. What is N? N is equal to PV by RT, right? So what is N1? It is PI V by RT1 plus PI V by RT1, which is equal to N1 dash, means it is final. It is final. So PF V by RT1 plus, here it is PF V by R. Now the temperature is changed to, you see, for first system, both the temperatures are same. So that's why we have substituted T1, T1 here. But in case of the second system, final temperature is T2. So I have to put T2 here. So what I have in the left hand side, I have 2 Pi V by R T1. This is equal to, so PF, PR is common, so take it out. And 1 by T1 plus 1 by T2 will be there. And on taking LCM, I'll have T1 plus T2 divided by T2. T1 plus T2 divided by T2. Okay. Then, so volume is common, so cancel. R is also gets cancelling, and the PF, the final pressure will be of 2 Pi. It is 2 Pi, and it is T2 divided by T1 plus T2. It is T2 divided by T1 plus T2. Okay, divided by T1 plus T2. So now you can see here we should have T1 and T2, right? Here T1, T2 will be there. So T1, T1 also gets cancelled, and we get T2 divided by T1 plus T2. Where it is given in option C. It is given in option C. Okay. The final initial temperature is not changing. Pressure and volume, they all remain same, but in case of final thing, temperature changes for the second one. Okay. So moving on to next question. Question number 51. The mass of ammonia in grams produced when 2.8 kilogram of dinitrogen quantitatively reacts with 1 kilogram of dihydrogen. So this is actually the Haber's process, right? Where N2 plus 3H2 giving to NH3 equation. So from this 2.8 kilogram of nitrogen, 2.8 kilogram is the mass of nitrogen. And to find out the number of moles, what we have to do, divide mass by molar mass. Molar mass of nitrogen is 28. And the number of moles of nitrogen reacting here is 0.1. Okay. And for hydrogen, you can see 1 kilogram of dihydrogen is reacting. So it is 1 divided by molar mass of hydrogen, that is 1.2. 1 by 2, it will be 0.5. And initially there is no reaction, and there will be no moles of NH3 produced. So since 1 mole of N2 produces 2 moles of NH3, so 0.1 mole of N2 would be producing 0.2 moles of NH3, right? 0.2 moles of NH3. So we do not know the number of moles of NH3 produced, and now we have got that 0.2 moles is the number of moles of NH3 produced. Now, from the given number of moles, we can find out the mass of ammonia, right? So number of moles is equal to mass by molar mass. And what is a mass? This number of moles into molar mass. So the number of moles is 0.2, and then molar mass of NH3 is, for nitrogen it is 14, and for hydrogen, since we are having 3 hydrogen, it is 3 into 1. So 3, the answer will be 17. So 0.2 into 17, which will be equal to 3.4 kilogram. And in terms of grams, we have to find out, right? So it will be 3,400 grams. 3,400. 3.4 into 10 to the power 3 gram. Okay, so the answer is 3,400 grams. Got it? Yes. Coming to question number 52. The complete combustion of 3 gram of ethane gives X into 10 to the power 22 molecules of water. The value of X is. So what we have to find out, the value of X we have to find out, and atomic masses are given to us. So let me find out the number of moles of the component first of all. Number of moles of ethane, let me find out. So the number of moles is equal to mass by molar mass. The given mass is 3 gram. And the molar mass of ethane, the formula for ethane is C2H6, right? So for 2 carbon, it is 2 into 12, 24, and for 6 hydrogen, it is 6 into 1, which is 6. The answer will be 30. The molar mass of C2H6 is 30. So here it will give 0.1 mole. So 0.1 is the number of moles of ethane. Okay. Now let me write the combustion reaction of ethane. So it is C2H6 plus 3.5O2 giving 2 moles of CO2 plus 3 moles of H2O. So from where does this reaction come? So the general equation is CXHY plus 3N plus 1 by, we can, let me write the formula of alkanes. Let me write the formula, the general formula for alkane here for you. So the general formula for an alkane is CnH2n plus 2. Okay. So when an alkane is reacting with 3n plus 1 by 2 moles of oxygen, it produces n moles of carbon dioxide and n plus 1 moles of water. And here you can see the n value is 2. On substituting the value of n as 2 here in this equation, I'll get this equation, balanced equation. Okay. Now here you can see 1 mole of C2H6 is producing 3 moles of water. 1 mole is producing 3 moles of water. Okay. 1 mole is producing 3 moles of water. And now 0.1 mole is the moles we have got, right? So 0.1 mole of C2H6 gives 0. It is actually 3 moles, right? It is 0.3 moles of H2O will be produced. Okay. So 1 mole of C2H6 and this is 0.1 mole of C2H6. Got it? Now, we have to find out the value of Px. That is, we have to find out the number of molecules of water produced. So, the number of molecules in 0.3 moles of water will be equal to 0.3 into the Avogadro number, which is 6.022. Let me take it as 6 into 10 to the power 23. So, which is 18 into 10 to the power 23 molecule. Okay. So, what is the x value? It is 18. 18 is the value of x. The value of x is 18 here. Got it? Yes. Now, coming to the next question. A proton and a lithium 3 plus nucleus are accelerated by the same potential if lambda wavelength of lithium and wavelength of proton denote the de Broglie wavelength of Li3 plus and proton respectively, then the value of lambda Li by lambda P is x into 10 to the power minus 1. So the value of x is. So again we have to find out the value of x. So we know that lambda can be calculated from h by root of 2 into m into q into v formula. Okay. So on taking the ratio of wavelength of lithium and wavelength of proton, so we'll get HH gets cancelled and we get it is as root of mass of proton into the charge. Charge of proton is 1 E, right? Only 1 electron will be there. So we substitute as E and V is there. Divided by the mass of lithium and the charge of lithium is 3 plus. So I have to put 3E here. 3 is a charge and into V. So now E gets cancelled and VV gets cancelled. The remaining we are having root of MP by MLI. Now since the mass of lithium 3 plus is equal to 8.3 mass of proton, the mass of Li 3 plus is equal to 8.3 mass of proton. So I can substitute I can substitute 8.3 MP in place of this mass of lithium. Okay. So what I will get? I'll get M into P in the numerator, and the denominator I will have 8.3 into MP, and 3 is there. Okay. Now MP, mass of proton gets cancelled, and I'll be having root of 1 by 8.3 into 3, and 8.3 into 3 is 24.9, right? And 24.9 can be taken as 25. So it is 1 by 25, and root of 1 by 25 is nothing but 1 by 5. So the value of 1 by 5 is 0.2, and 0.2 can be written as 2 into 10 to the power minus 1. Okay. So this is the ratio of the wavelength of lithium and the wavelength of the proton. Okay. Whose the x value is 2. So the value of x here is 2. Okay. Yes. Now coming to the next question, which is the last question of this session, is that a certain quantity of real gas occupies a volume of 0.15 decimeter cube at 100 atmospheric pressure and 500 Kelvin when its compressibility factor is 1.07. Its volume at 300 atm and 300 Kelvin is dash into 10 to the power minus 4 decimeter cube, and compressibility factor is given as 1.4. So what is compressibility factor? It is represented by the letter Z, right? So we know that Z is equal to, compressibility factor is equal to PV by nRT. Okay. It is PV by nRT. And we are asked to find out the final volume, which is V2 here. Now how to get, we need all the terms, pressure, compressibility factor, and R, T, V, everything we need. Okay. So number of moles cannot be find out. So number of moles has to be find out first. So it is equal to PV by Z into RT. Okay. So you see the compressibility factor Z1, it is equal to, it is actually 1.07 at first, and during that time the pressure is 100 atmospheric pressure, 100 atmospheric pressure, and at that particular pressure the volume you can see at this pressure it is 0.15 decimeter cube. It is 0.15. It is not actually 0.15. There is a mistake here. It is 30.15. So I'll take this as 30.15 decimeter cube, which is equal to 30.15 liter. Okay. And the temperature value. The temperature value will be, so the temperature value will be 500 Kelvin. Temperature value is 500 Kelvin. Okay. So actually in terms of decimeter cube, you will have 0.030 decimeter cube. Okay. Only in terms of liter, we have 30.15 liter. Okay. So in terms of decimeter cube, it is 0.0 0.030 decimeter cube I can take. Got it? Now coming to the second compressibility value, that is Z2 is 1.4, and at that compressibility factor value, the pressure is 300 atmospheric pressure, and the volume only we have to find out, it only we have to find out, and temperature T2 is given as 300 Kelvin. It is given as 300 Kelvin. Okay. So let me equate these two. So that is P1 V1 by Z1 RT1 will be equal to P2 V2 divided by Z2 RT2. So R is common and this is equal to N. Okay, R is common. So just you cancel on both the side. So substitute all the values here. P1 is 100 and V1 is 0.15 and Z1 is 1.07 into the temperature is 500 Kelvin, which is equal to P2 is 300 and V2 only we have to find out. Z2 is 1.4 and T2 is 300. Okay. So on cancelling everything here, we get B2 as 1.4 into 0.030 decimeter cube divided by 1.07 you will get, and it will be equal to 392 into 10 to the power minus 4 decimeter cube. So this is your final volume B2. So from this, what is the value they are asking? It is 392 into 10 to the power minus 4 decimeter cube. Okay. So the answer is 392. Yes, students, I hope this session is very useful to all of you. So I'll meet you in the next session. Okay. Thank you so much. Thank you so much for listening. Bye bye.